All right, let's derive the formula for a car that is going to go around a flat curve. That's embarrassing. Around a flat curve in this path here. We know there's going to be a centripetal force pulling on the car towards the center of this circular path. The distance from the center to the location of the car is the radius. Let's do that and talk about the mass of the car when we get there. And so this is going to include friction. So the friction is going to be what makes the car go in a circular path, and it will be static because once the car starts to slide, if it's skidding out of control, then it will be kinetic because the two surfaces are sliding against each other. So let's just know that this is going to be static friction towards the center. So what is this going to look like? Well, we know that the force centripetal is going to be equal to the mass times the centripetal acceleration. So in this case, it's going to be the force of static, which is going to be equal to the mass times centripetal acceleration. This is going to be mu s, mu static times the normal force will be the mass times, well, I'm going to switch to centripetal acceleration at this point. I'm going to substitute v squared, the velocity squared over the radius of the circular path. In order to do that, in case you're looking at this later. And then let's take a look. We can substitute the weight for the normal force. That's going to be the velocity squared over r. We can cancel out the mass. And the reason the normal force is just going to be mg is because the car is on, let me make ground. Why is this not changing colors? It's going to be on flat ground, and the weight will be straight down. And so the normal force will go straight up. Should be in the middle. And if we were looking for the velocity, we would multiply both sides times r. And that will give us r g s is equal to v squared. I'm going to flip it and take the square root. And that should give us the formula for the velocity to go around that circular path safely.